Hi, everyone. Welcome. Hopefully, this is your last session of the day, probably. My name is Facundo Santiago. I'm a principal PM at Microsoft. And today, we're going to show you how we can create multi-agent autonomous systems by combining the power of GitHub and Microsoft Foundry. We have code, we have demos, and well, we're sorry we don't have swag, but probably we are entertaining. Let's get this started. So you have heard probably till now multiple sessions talking about the AI shift, right? And for me, the most fundamental change about the AI shift is related with the fact that certain things that became possible not that long ago now are very, very practical. And at the enterprise level, this transformation is even more profound, right? Like organizations can now take actions and make decisions at incredible speed, automating operations from customer services to R&D and whatnot. But this is just the beginning, right? So agentic AI represents a next wave of transformation, where AI moves from being reactive to being proactive. That when systems can understand actions, take initiatives, and orchestrate workflows to deliver value. But why are we talking about this transformation now? So if you attended Ignite, probably last year, you got tired of hearing the word RAG, right? And those are systems that have access to knowledge. And when a user makes a question, they will try to look for relevant documents, most of the time using a vector database, right? To then feed a large language model to then generate, hopefully, a plausible answer. Although those systems became really popular, and they still are, don't get me wrong, they are fundamentally passive. That means that you make a question, they generate an answer, period. And we know that most of the business processes these days are not like this, right? Employees have to make to query dispersed data sources, to gather information. They need to reason across multiple inputs, and then take actions in multiple transactional systems across the organization. And if you try to automate such a thing, it comes with its own challenges, right? So they do require a lot of data parsing and data structuring. They also require you to connect with transactional systems that are not well integrated or they don't have well-defined APIs. And finally, if something doesn't look exactly as you need it, they just break. And these are exactly the things that agentic AI comes here to change. First, models now can have the capability of reasoning that allow them to do planning. Then models can also execute actions via tool calling. And finally, they can learn from experience because they have access to context. So they can tell where are the things that work and where are the things that didn't work. So these three things actually represents the fundamental pieces of the agentic transformation. And as we said at the beginning, what was not possible before now is extremely practical. So agents can interpret and structure inputs. They can query multiple data sources and parse data very, very efficiently. This is something that most of the models will get extremely well. Models can interpret APIs and even UI and take action if they change. And finally, agents can handle exceptions, basically retry tasks and resolve what was the biggest problem before, was the edge case, right? And adjust the tool calling if it is needed. So then, if you actually combine all of this with an event-driven architecture in your system, then you unlock the ability to fully automate end-to-end business processes. Now agents can respond to triggers, like a new customer request, like a failed transaction, or a status update, and take an immediate intelligent action. Hopefully at this point, I convinced you why the agentic AI represents such a shift in the world of automation, which is also why there are multiple platforms to create them, right? And you will continue seeing them. But a good way, at least for me, to think of them is think in the same terms of SaaS, PaaS, and IaaS. Right? So in one side, you have SaaS applications, for instance, like Copilot Studio, that allow you to create agents without writing a single line of code. On the other extreme, you can go full code, full infrastructure, and develop your agent in the same way you develop, for instance, a distributed application. And then in the middle, you have platforms like Microsoft Foundry that allow you to develop these agents using building blocks, using either the UI in the portal. You can also use the family of SDKs that it offers, or you can even deploy full code solutions into the platform. So you actually have the full spectrum here. Today, we're going to focus on creating applications using code. Although it requires some experience, that's true, it offers high level of flexibility and customization that most of the time automating business processes and organization in real life requires. And this is also the reason why it should not come to your surprise that you have choices, right? So there are multiple AI frameworks out there that allow you to create these agentic AI applications, designing, building, and orchestrating AI solutions. While each of these frameworks make their own choices, they do provide a consistent programming language within them. So the programmer can make sense of it and deal with that. And personally speaking, I think this is a very important concept because when you borrow a framework, when you borrow one of these agentic frameworks into your application, you are also borrowing a set of ideas, concepts, lessons learned from those frameworks into your application. And earlier this month, we have announced the public preview of the Microsoft Agent Framework, which actually combines all the years of experience of running semantic kernel in production at Microsoft with the cutting-edge flexibility that we have seen people using with AutoGen, another very popular open source framework. This new framework is open source, is interoperable, is community-driven, and is ready for production. And it represents Microsoft's take about how agentic AI applications should be built. So to put these concepts into practice, let's actually try to solve a real problem. So I propose you to step into the shoes of a product manager at Microsoft Engineering. So part of my job as a product manager is to manage the customer feedback, right, and ensure that translate to the right actionable items to engineering. And I don't want to point fingers here, but sometimes I may get feedback that looks like something like this, right? So there may be an issue in a repo that I manage that is not very well formatted, so I need to adjust it so I can read it more easily. Then the request may be a bit vague, right? Like, so I need to do a small research, try to find out relevant files, or fill the technical details that may be missing on the issue. Finally, most of the time, like these issues are poorly documented. So this requires us to rewrite the issues in actionable items that we can actually pass to engineering. This is something I had to do each time you open an issue in one of the repos that I support. So a question we may ask is like, can we make an agent do this for me or for us? And that's precisely what I'm going to try to do today in this session. Let's try, I propose you to create this intelligent system that each time a GitHub issue gets created, it's going to pass for multiple stages. First, we're going to try to format and make sure that it adheres to the writing guidelines of the repo, and it has the appropriate label. So if it is a bug, if it is a feature, they should be applied. For feature requests, we probably need to do some investigation, try to find out what it would take to actually solve that feature request, try to fill in all the technical details, and try to find out if this is something that probably someone else also reported. If it is a bug on the other side, probably we need to do a root cause analysis, try to find out all the situations where this may occur, where are the pieces of the application that have been impacted by this, and if this has been reported before by another user. Finally, we need to combine all this information to do a breakdown and translate that to actionable items that we can actually pass to engineering to work on. What do you think? Does it look like something interesting to do? Let's try to figure out that with Catlin, Senior PM at GitHub. I'm going to show us how to do it.
Oh, thank you, thank you. Thank you so much, Fecundo, for that. I am stoked because I get to show off the new AI toolkit, and I'm going to change the screen so you can see it. There we go. OK, and this brings together three very good things. One is GitHub, one is Microsoft Foundry, and one is the new Microsoft Agent Framework. And with their powers combined, we're going to take you like way beyond VS Code. Even though I'm looking at VS Code, you're not just writing code here. You're going to test prompts. You're going to test models. You're going to deploy an entire agent. It's going to be awesome. So let's look around. If you want to try out the AI toolkit, you're going to find it in the left-hand sidebar right here. And I think the most important place to start is the model catalog, because I used to be a GitHub Models PM, and I'm biased. So let's show off which catalogs of models we have in here. First off is GitHub Models, which is going to give you a lot of like name brand models, right? Like your GPTs, your llamas, et cetera. And then we scroll down and we have the Microsoft Foundry hosted models. This is a catalog of 11,000 models. So if you want that one specific finely tuned OSS model that does this like one very specific thing that you need, you're gonna find it here in the Microsoft Foundry hosted models catalog. But if you want more, we can keep scrolling down, and you can see here that we also have third-party models available, so like the sonnets and some others, and then last but not least, you can bring your own model. So if you've got your own model key, we've got BYOK available for you, and if you click into any of these, you can quickly open and see more details about any of them, like token usage, what it's good at, etc., so that you are making sure you're picking the right model for your use case. But what are you going to do with all these models? You're going to build an entire agent, and you're going to do it through like a cool low-code AI, and we're going to do it right now. So I'll go ahead and open the agent builder. I've had a lot of tea today, everyone. And this isn't what I want. That was me practicing earlier. Okay, so let's go back to talking about the use case that Facundo introduced. So I'm a PM, right? People send me issues all day long. Some of them are bugs. Some of them are feature requests. If it's a bug, I need to do something about it a lot sooner than I do for a feature request. And this is a thing that is so real in my life that I actually tried to build a GitHub action to do this summer. So once a day, an action would run, and it had a GitHub model in it, and it would like scan this community forum for bug reports and create an issue. But there was still like a lot of manual, like Kate had to go in and do this thing, and it was just like too much work, okay? But now, what I want to do is, rather than having just like a little bit of automation going on, I want a fully autonomous agent. So this is no longer a Kate problem, this is an AI problem. And that gets us to what Facundo was talking about with fully offloading and making something autonomous. Dun, 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 dun. So with an agent, we can bake that intelligence into this workflow and make the agent do the whole thing. So let's call this Kate's PM buddy. And I'm going to give it instructions that are pre-written. So we'll paste those in there, and basically what this says is exactly what we already described, right? Like, take an issue, format it better, make sure there's code blocks and stuff, and then make sure it's labeled as either a bug or a feature request so that we quickly know how to triage it. That's our goal. Okay. And then a really cool part and important part about this AI toolkit is also that we have this playground in the right-hand bar here. So you're not just like sending code into a black hole. Like, you're actually going to test it and see if it's working in real time. So let's look at this issue we were seeing before that, like, it's kind of vague, right? And I'm going to go ahead and copy and paste it over here so we can test out if this is working. And look at that. Okay, so the AI model is already running. It's already labeled it as an enhancement, which is correct. And it's rewriting the text to put that code block in. So it's reformatting for us. Woo! Everyone give our first little model a little round of applause. Okay, but wait, there's more, because I don't want to be copying and pasting text back and forth. That doesn't reduce my workload. I want it to just handle this for me. But in order for it to do that, it needs to like reach out to the internet and talk to GitHub, and that brings us to MCP. Okay, so raise your hand if you're super familiar with what MCP is. Okay, some of you. That's great, because I pre-wrote some jokes. So MCP is your Model Context Protocol. So basically what this is like an open protocol or like a communications agreement for how you talk to your AI or how you get all of these tools into your AI. And if that sounded like gobbledygook, let's break it down a little bit. You can think of MCP like a USB-C port for your AI. So you got a laptop, right? Normally, when you're not giving a talk, you also have like a mouse and a keyboard and a video and some speakers, and these are all different types of like inputs and outputs, but you need to plug them all into your laptop somehow, right? That's why we have USB-C, so that no matter what the inputs and outputs are, you can easily plug all of those into your laptop. So you can think of MCP like the USB-C for your AI, how you plug tools into your AI. Sounds simple, right? Wrong, because AI is exploding. And so as part of this, MCP, which is very important, is also exploding. And in the same way that you would not want to take like a spammy spyware keyboard and plug it into your laptop, you do not want an evil spyware MCP plugged in to your highly autonomous AI agent that is taking actions on your behalf. That could be very, very bad. So that brings us to this new MCP registry. So this is GitHub's attempt to give MCPs kind of a home. So these are all MCP servers that we have vetted as best as we can. And so developers can come here and feel confident that if they're using one of these, it's the real deal. It's not spyware, like this is sponsored by whatever company it's representing. And also providers can feel confident that like they got an MCP, they want to get the word out. If they put it in this registry, it's going to be viewed by thousands of developers. And we tried to make it really easy so you can install stuff easily from this MCP page. But it's even more fun to do it right from the AI Toolkit. So we're going to come back here, and then you'll see we need to add an MCP server. And for this specific use case, which is all about editing issues, I need the GitHub MCP server. Perfect. And then I need a personal access token, which I am sharing on this stage. And I understand that if you work in security, you are screaming at me in your head. But I assure you that this is only applicable to this exact one code space, so none of you can use it. Gotcha. So we're safe here. So now we have an MCP, and now let's see if it's actually working. And it's connected. So it should all be wired up now. And now we're going to go back to our agent builder and tell it to use that MCP. So first up, we need to change the instructions to be really specific and be like, actually do the work to call to the MCP, don't just say things. So now we'll pause and highlight this improve button. Because you know what's really good at giving instructions to AI? Other AI. So that's why we have this improve button to help improve your prompts for you. So we're going to say, add a line to specify that the model should call to the GitHub MCP to fetch and format the issue. Okay, cool. And then we're going to click go, and it's going to figure out like the most highly optimized place to put that in the instructions. And if some of you are looking at this and you're like, what are these instructions anyway? For those of you who are in the know with AI, it's just the system prompt for the model. For those of you who are new, welcome. This is nothing more than just how you tell the model like who to be, what to give back to you. So that has already run through there. Perfect. I don't have time to read all of it. Oh, but there it is. OK. So now we need to give the model access to the actual tools that come with the GitHub MCP. So we're going to click, first I'm going to get rid of that. OK, then we're going to click Tools, MCP Server, GitHub, that's the one we just added. But security friends, we know that we want to give least permissions to this model, right? Extremely important in AI security. So uncheck all those tools. And then what we want is just the ones related to issues. So recheck all these tools. And then click OK, and then we should be good. OK, we're feeling good. And now we're going to bring it all together. So we're looking at this issue again, right? Badly formatted, no label. And I'm going to copy this slug here, and it's issue number 9. And we'll go over here, and we say, you are assigned to issue number 9. In this repo. All right, the MCP has opened. It's reading it. It's used some tokens. It's doing some stuff. And now if it's working correctly, what it's going to do is actually call to GitHub and reformat that issue on the internet and add a label to it. And it's still thinking, so I should have memorized extra jokes for this part. But it looks like it's working. It seems to have applied a label, at least per here, and it added some formatting, which is very exciting for us. OK, is it done? Look, a label! Round of applause! just a quick reminder, we did all of that without writing a single line of code. There was no linear algebra. There was nothing complicated. I, as a PM, did this through this UI, which is awesome news. But we don't want to build just one agent, right? I like to have an agent per task and help them all work together in a swarm. So now I need an agent for the second part. And since I'm now a Copilot PM, I'd be remiss if I left the stage without highlighting Copilot. So let's go ahead and view the code for this. And we have to click this button too. OK, cool. So here we are. And there we go. Oh, interesting. All right, we are not going to show the Copilot part because I didn't install it on this code space. But we could go into Copilot chat and we could quickly run some instructions that basically said, like, hey, now recreate this entire agent, but if it's a bug, investigate how to resolve it. And we could watch this whole thing flow and have it write all of the code for that. But we don't have time to do that because we're going to return it over to Facundo again to take us home. So thanks, everyone.
Thank you, Kate. That was fantastic. And thanks for the energy. So Kate showed us like how we can go from prototyping super quickly into code to create our first agent. And maybe a valid question is like, why we cannot keep going, right? Like, one cannot put more instructions there, put everything that this autonomous system needs to do, just like increase adding the prompt and adding more. Well, you can definitely try doing that, but you hit some issues in the process. The first one is related with instructions, right? And the format agent that we just saw was simple enough, and yet it has a very long and detailed instructions to control precisely what it does. And as agents perform more tasks, they need more detail of control to actually make sure that they do what we want them to do, which makes them harder and harder to maintain. So when you have different agents, as Kate was mentioning, all those instructions are private to each of these agents. So that means that you can iterate over them, you can maintain them, and improve them as you move forward in your development cycle. The second I want to mention is about tools. So as agents need to do more things, they need access to more tools. And as the number of tools increases, also the chances that the model will pick the wrong one for the wrong job. Sorry, for the job that you want to solve. So we saw that when Kate added the GitHub MCP server, right? Like that one on its own has more than 100 tools provided to the model. So this scales super, super quickly. So having each agent having access to only the tools that it needs not only ensures that the agent can do anything that it shouldn't be doing, but it also increases the probability that the agent will pick the right tool for the job that it has to do. And the last one I want to mention is related with context. And I'm sure everyone here is familiar with context, or at least is familiar with how much it costs, right? Because basically, as agents perform more tasks, the context that is associated with those tasks gets bigger. And bigger context means more money. And it also represents challenges for the model. Even for those models that claim having very, very long windows, they do present challenges for processing very long context windows. So in a multi-agent system, it's not required for you to share the context across all the agents. Each agent only needs to know exactly the context that is relevant for the task that it has to solve. So this results in a more efficient use of the context, but also in a more economic way of handling tokens, because you're not moving context back and forward to the model all the time. So essentially what I'm saying is not new. It has been in the software industry for years. Do not build monolithic solutions, divide and conquer, right? And this is when the topic of multi-agent architectures come into play. Right? Like if you have not heard about this is basically well-known ways of organize multiple agents in a way that they can solve a complex problem more effectively. They will, for instance, like take advantage of things like collaboration, segregation of responsibilities, or prioritization of tasks. This is a talk on its own, so don't worry, we won't deep dive in this. But I wanted to talk want us to talk about custom solutions, which is workflows. So basically, in a custom workflow, in a multi-agent workflow, we decompose a problem into a sequence of subtasks. Each of these subtasks taking inputs and producing outputs to the next task, right? So those workflows can connect other agents. They can also connect code. that we wrote. And they can also connect humans that can verify the outputs of those agents before moving those outputs to the next agent on the sequence. And as organizations become more and more familiar with these workflows, less and less of these humans in the loops, in the way that we name them, are required in your workflow. So let's see how we can actually build a multi-agent system using the agent framework that we just mentioned before. Let's go now to my laptop. So we're back in VS Code. And we have here I have instantiated 4 agents. That are the 4 agents that we mentioned at the very beginning, right? Like we have the issue formatted agent, we have the investigate agent, the root cause analysis agent, and the refinement agent. These 4 agents were created exactly in the same way that Kate showed us before. The only thing I did is like put it in a class because we're fancy people, but no more than that. Then the other important thing about this is like the instructions of each of these agents is placed inside of the GitHub repo. This allowed me to iterate over them, improve them, and know exactly how they are changing. For instance, let's take a look at the investigate agent prompt. So you can see it's very detailed. It has very long instructions about how to understand the issue, how to search for relevant code if it is needed, how to deep dive in the code, and how to verify that actually we got all the information that we need, right? So this is a pretty sophisticated agent. Once we instantiated all the agents, the next thing I'm going to do is to build a workflow. We're using here the agent framework, and building workflows with the agent framework is pretty simple. The first thing I want to do is actually to add all the participants of the workflow that we need. In this case, the 4 agents that I just created before. The order here we add the agents is not relevant. But what is important here is to tell which of these agents is the one that needs to start. Right? So this is the one that's going to get the first request, in this case, the format agent. And then we need to tell the framework how to transition from each of the agents to the next one, right? How to move. And we do that using the add edge method. So if you see here, we're saying that it needs to transition to investigate agent only if the issue has the label enhancement. If it has the label bug, it needs to transition to root cause agent. So this has label condition. It's just a Boolean function, nothing pretty there, that returns true if a given label is present on the issue or returns false otherwise. So nothing special here. Finally, the last step is to transition from both of those agents to the final stage, which is the refinement agent, right? And that's it. We have built a multi-agent workflow using the agent framework, right? Let's give it a try and see how it works. There are multiple ways to run a workflow locally here in a machine, but one of the, or at least the one that I find most interesting to me, is using a tool called 𝗦𝗽𝗲UI. 𝗦𝗽𝗲UI is a tool in the agent framework that will do 3 things. The first one is going to package your agent in an API. Then it's going to run it in a web server. And then it's going to spin up a UI for me to connect to that API so I can talk to the agent. Let's take a look and see how we can actually do that. OK. So I have that in, So it's UV, run, Python, pmbody, main.py. I have that in dev UI. There it is. So it's going to spin up the UI. And we're seeing here is actually the UI from agent framework. As you can see, I can quickly execute the workflow directly here. We already have one. One issue that we can work on is the issue 104. So let's assign that issue to the workflow. Say like you are assigned issue number 104 at this repo. Hopefully it appeared correctly. Let me copy just in case, so we don't have regrets. And I click run workflow. So you can see the UI, while this is running, is showing us a representation of how this workflow looks like. It's also showing us some events that it started to emit while this is being executed. And it's going to also give us all the information, like, for instance, the traces that this is emitting as it made progress into the workflow. OK, we can actually see that it started. If we go here, like, it has completed the format agent, and now it's in executing investigate agent. And we can actually see that it has done things here. So it has applied the formatting. And something that we can see also, if you notice, is it has changed the title to improve accessibility across the app. But if you pay attention, the user that actually made this change is 𝗵𝗵𝗸𝗶𝗵. So this is actually a GitHub app. So I have created a GitHub app and assigned that identity to my workflow. So this is pretty handy because now I can know what is this workflow doing, because it would always use that signature to do that. And I can also control, give it permission, which are the things that this agent should be allowed to be doing, and which are the things that should not be allowed to be doing. We can also see that 𝗵𝗵𝗸𝗶𝗵 has added a label enhancement, but also added a label investigate. This is also another enhancement that I did in the workflow. So basically, this tells me that the investigate agent is working right now. So when the investigate label is applied, that means that investigate agent is working, and so forth and on. Right? Let's take a look at one that is completed, because the workflow takes some time to execute. So this issue is already completed. We can see that it has posted a comment saying a description about this issue, why it is important to get solved. It has also looked to the code and has found some files that need to be updated if you want to enhance, as this GitHub issue is referring. And it also found some related issues that we may need to take into account because they are talking about the same thing. We can see, too, that it has removed now the label investigate. That means that investigate agent is done. But now needs refinement was added. That means the refinement agent is working right now in the issue. And as we can see, it has decomposed all the information gathered into actionable items that we can actually send to engineering. And even in some of them, it has identified them as quick wins. So we can actually prioritize which one to work first and which one to work later. Right? And then it removed the label needs refinement. That means that the agent is done. Right? So it looks like we have solved the problem, right? Like, so this looks to be everything that we needed, or at least that we said at the beginning. So are we done? So I really encourage you to do not fall with these kind of prototypes, because dealing with a multi-agent system in production is far, far from this. It's not trivial. So I'm going to talk about, like, some of the key things that you need to have into consideration if you're moving these kind of systems to production. The first one is related with reliability, because a multi-agent system is also a distributed system. So here, reliability compounds negatively. That means that if the workflow fails in a step a long time ago, that may propagate to your entire system and make it fail catastrophically. The second one is about token economics, because, like, these multi-agent workflows have the power to like redefine your tokens economics really, really quickly, really amplify the tokens consumption that your agent may be consuming, even with a single request, because, like, these agents may make hundreds of calls to LLMs. And finally, it's really, really hard that you get this right at the first attempt. Right? Like, so you really need a way to deliver these changes incrementally and deploy them as you are learning in the process, as you are, like, improving it. You really need a way to deliver these changes in a controlled way. Fortunately, solving these problems is not a mystery. It just requires discipline. Right? So first, like, you really need observability. Like, you saw this agent doing a lot of things, and you had no clue about how it came up with that, right? So you really need a way to deep dive and see what the agent is doing under the hood. Then the easiest way to solve token economics, use the right model for the right job. Like, we saw the format agent. That is a very simple task. You don't need a very sophisticated model to do that. And finally, if you do everything, something that you can check inside of your repo, you just enable continuous integration, continuous deployment. So those are things that we have all learned from the software industry. Let's keep them applying to AI solutions. And this is why running in a platform like Azure AI, like Microsoft Foundry is paramount, right? Because Foundry actually assists the developer in the end-to-end development lifecycle, providing models, agents, tools, observability, all within a comprehensive framework of security and management. So let's try to reach production then with this agent and deploy it to Microsoft Foundry. So the simplest way, there are multiple ways, of course, to deploy to the cloud, but one of the simplest one is using a tool called ACD. So ACD is a CLI tool that allows developers to deploy infrastructure plus application in a single go. And the good thing about this tool is that Microsoft Foundry has an extension for it. So you can actually create agents and then deploy them with ACD in a single go. Let's take a look at about how we can actually do that. So let's go back to VS Code. And the easiest way to get started with ACD is from a template. So I'm going to do ACD init. I'm going to pass one of the started templates for Microsoft Foundry. What this is going to do is going to initialize my repository with all the infrastructure that I need to actually create solutions based on Microsoft Foundry. It's going to ask me for a name, so put it Ignite 2025. And that's it. So what it has provision is like all the files that I need to deploy the infrastructure required to develop with Foundry. We can see that here in my, oops, that's a lot of zoom. OK, it doesn't want that. So if you see here the infra folder, it has bicep files that you can inspect, you can modify to make them comply with the organization. But basically, those files has the basic scaffolding that you need to deploy this agent to the cloud. The next thing we need to do is to add our solution, right? And for do that, I already added the specification here inside of this YAML file. If you see, I have added a new service called 𝗬𝗲𝗶𝗫, and it's pointing to the source of my code, and it's using the Azure AI agent extension to package everything inside of a Docker container with some configuration, like the amount of CPU, memory, and everything that I need to do. So that's everything that I need to do in order to package my, my agent. So I'm going to do now ACD up. What this command is going to do is going to do three things. It's going to package my solution, it's going to provision all the infrastructure that it needs to run this in the cloud, and it's going to deploy the application to it. And the interesting thing about this is that it's not going to deploy everything in each time. It's going to tell which are the changes that happen between the last execution that I did and the next execution that I did. So this will probably take some time. So I'm going to skip that and see one of the agents that are deployed. So if we go here, back to Azure AI Foundry, we can see that the 𝗬𝗲𝗶𝗫 has been deployed. And something that we can see is like it has a Docker image that is running this agent and some replicas, which is the amount of instances that I have of this agent. I can do traces, I can monitor this, and I can evaluate this agent directly. And talking about evaluations, something that we mentioned before was about like the token economics, right? And we mentioned that the format agent was probably an agent that didn't need a very powerful model to actually get executed. So we can change that to use a different model. And that's something I already did. So we got, here we have the format agent, and I have changed it to use the model router. So model router is a model that comes in Azure, in Microsoft Foundry that automatically selects the best model based on the complexity of the prompt. So simple prompts will get simple models, and complicated prompts will get complicated models, right, like GPT-5. But the other version, if you go here to the different versions of these agents, in the previous version that we were running, and the one that I showed in the demo, was using GPT-5, right? So how can we make sure that if we change from this GPT-5, from this model router that promised us to select the right one based on the complexity, actually is impacting the performance of our model? And for that, what we can do is evaluation. And you have to approach this in exactly the same way like software engineering, right? Like you do unit testing in each of the pieces of your system, and then once that pass, then you do integration in your entire system. So we need to do unit testing in this format agent to make sure that changing the model doesn't affect the performance of this particular one. And this is exactly what I did. So if you see the format agent, here we have the two executions of this evaluation. We see the evaluation with version 5, here is mentioned, and another evaluation using version 4. If you remember, version 4 was using GPT-5, and version 5 was using the model router. So the question is like, is this performance the same? And we can actually test that. And here we can see the numbers of this evaluation. So this evaluation has 10 different issues that I benchmark both of the versions of the agent to know if they compare one with the other. So we can see that in both cases, the agents remain on task, meaning that they do what we ask them to do, but the score that they get for the completion is a bit lower for the case of the model router, which makes sense, right? Because you know that there may be a smaller model running those instructions. You can actually inspect this and drill down exactly, okay, let's see exactly what is the thing that the agent didn't get in this case. And if you see, I can inspect each of the issues that I gave it to the system to classify, and we can see that in this particular case, it didn't pass the benchmark because it did the formatting, it did everything, but it didn't apply the labels as it was expected in the instructions. So probably it forgot one of them. So you can use this strategy to actually make sure that the changes that you're applying to your system do not alter the quality, or at least you are conscious that you're trading money for the quality of this particular model. So we deployed incremental changes using ACD in the cloud. We applied changes to the agent so it has the right model economics to deal in production. And we're missing one thing. What do you think is that thing that we're missing? Well, we already did that with ACD. What is the single thing that you should not forget about this session? You should not deploy multi-agent system in production without observability. You definitely cannot do that. And the good thing is, like, if you deploy to Foundry, that is out of the box. So there is nothing you need to do, at least if you're using the Microsoft Agent Framework. If you're using probably another, you need to set up something. But if you're using that, observability is enabled by default. So let's take a look and actually see how those traces actually look like. So we have here a couple of executions of the PM body. So let's take a look at one of them and see how they look like. And the first thing we can see is that this execution took or involved 3 agents: the format agent, of course, investigate agent, and the refinement agent. We can see how much time it took and how many tokens that consumed. We can see that, for instance, the most expensive of these agents is the last one. So you can actually see where your money is being spent. But let's drill down in one of those agents. Right? For instance, the investigate agent. So you can see here that this agent is doing a lot of things. Like it's searching for code, getting file content, searching issues, getting more code, getting more issues. So it's really making progress until it makes that GitHub comment that we saw on the website to then finally generate the report that we saw before, right? Which is here. Oops, again. And then this report is being sent to the next agent in the workflow. So as you can see, this kind of tools is paramount because you can see how the information flows from one of the agents to the next one and to the next one. And if something doesn't work as expected, then you can actually see and track down why that happened. Did I hit that? Yeah. So hopefully till now, you saw the power of applying agentic AI into automating a business process and why this represents the next wave of innovation. And this is also why I'm thrilled to see customers like, for instance, 𝗦𝗲𝗲 leading the way, building agents and workflows with GitHub Copilot, Semantic Kernel, and Microsoft Foundry. Let's see this short video and see how 𝗦𝗲𝗲 is leading with agentic AI transformation.
My team and I support our engineers, but everything we do in technology at Levi's ultimately serves our fans. So what my team and I work on are things like observability, quality engineering, release management, integrations, CI/CD pipeline.
We rolled out GitHub Copilot to the teams. 40% of the prompts were accepted into our code base after the first prompt.
There's going to be some differences in terms of how our engineering teams use GitHub Copilot. Where we have more senior members of the team, as agent mode evolves, we expect that's almost going to operate as a junior developer supporting them in their roles. If you have a more junior engineer, GitHub Copilot will help upskill them in terms of their engineering practice. GitHub Copilot is a really important part of that. We already know we have great technology talent. It's really going to augment our engineers in such a rich and powerful way and act as a force multiplier for them. This is going to make them even better.
And with this, we reached the end of the session. I really thank you for being with us today. Some calls to action. Start building agents using GitHub Copilot. Download the Microsoft Agent Framework. It's free, it's open source, and ready to be used in production. And as I mentioned, if you are going multi-agent, do not write blind. You really need a platform like Azure AI Foundry to know what is going on. Thank you.